Hello everybody, my name is Anurag Agarwal and I work for Tata Consultancy Services as a solution architect and with a prime focus on 5G and its enabling technologies. And I have one of the key technology which I take care of where we do solutions and prototypes and other proof of concepts is the edge computing area. So I personally look into edge computing as well as other enabling technologies, be it network slicing or a bit of IoT as well. So that's where I got some interest on when I was working on IoT. I got interest on how edge computing can help me deploy industry solutions into the field and still be able to utilize my current infrastructure to greater extent rather than wait for 5G to help me out and start deploying the applications. So as part of this today's session, we have divided the session in basically two parts. First, I'll just cover all the APIs, what Anurag Ranjan has talked about. In the previous session, we saw that reference architecture from Intel, the NEV SDK, and I'll just quickly cover, very briefly touch upon what is MEC, what is NEV SDK, and then I'll just jump into NEV SDK management APIs, which is MM5 interface. Then we will jump into MEApp APIs, which is MP1 interface, and then we'll also go through some of the traffic routing. How do we create routes or traffic routes within the NEV SDK? So we'll also cover those aspects as well. Then we'll give you some time to hands-on. We'll have one server available with us today. Maybe we'll just divide into smaller groups and collectively we can do some hands-on just to play around how the API is going to look like and how, if we do application development, what things we need to ensure while we are developing application using NEV SDK. And the last, I'll cover one of the use cases that TCS has developed using this NEV SDK. So moving on. Okay, before we jump into that, I want to show you one of the use cases, what kind of use cases we can develop on the edge computing. I'm pretty sure that all of you must be most of you are working in the edge computing area, so you must be developing very interesting use cases. One of the use cases which I have been working is, how do I optimize my road traffic specifically for emergency traffic, especially in countries where you're or in the cities where your traffic conditions are very, very stringent, especially let's say, for example, New York or Mumbai or New Delhi, where road traffic is so heavy that it's very difficult, even with all the current available solutions for emergency vehicles to get a pass. It's still very difficult for them to get a free passage. So we have come up with an ideation. Can I control this entire infrastructure remotely as well as at my near edge? So typically what happens is you have mobile tower which typically covers like few hundred meters or few kilometers, depending on the strength. Then, so can I use that edge to control the traffic of that particular area? Can I deploy some application at my radio edge, so which can have the knowledge of the current traffic situation at that point of time, at that particular place, or that particular signal, and can I route the traffic from there to the remote location using my edge application? So let's see like a traffic scenario. Say I have an ambulance coming in. So how will my ambulance tell where I need to go? So that can be controlled by my centralized analytics engine, a centralized traffic controller. So they as soon as it comes in, it just goes to my radio, and which will redirect the traffic towards the edge traffic controller, which will say, okay, you have this traffic here. It will redirect my traffic lights to tell them you have to switch it on based on what parameters? Okay, it has number one, all the current traffic or I can say the car counts, because basically if it's a connected car scenario, so my cars are also talking with my infrastructure, so they would know, okay, how many cars I have at this point in this particular junction, and based on my previous history or daily history, I would know how much time does it take at this hour of the day to clear the traffic from this particular junction. So I can estimate how much time it would need for an ambulance to reach this junction point and how much time I have to clear this entire traffic. So I can plan it accordingly and instruct the traffic junction or traffic lights to start green signals on the particular direction so that my entire traffic is cleared off. So that once my ambulance reaches there, it does get a free passage. So my edge controller traffic, my edge traffic controller will use my another application which is again deployed my traffic radio edge traffic analytics engine, and will instruct back my ambulance and the traffic lights. But at the same time, they will also go back to the entire centralized system, update their system, and it will instruct this entire free passage for my signal. This is just one of the use cases that we have been brainstorming how to solve one of the field problems. So how edge computing can help you there.
So one question there, can you go to the view side? What is the difference between the central analytics engine there and the traffic analytics on the edge server?
Yeah. The central, the traffic analytics engine at the edge typically takes care of the traffic signal within that particular scope, because one radio station has a limited radius. So all the traffic signals within that scope will be as a localized analytics. It will be doing only the localized analytics. It doesn't need to send everything back to the traffic controller. Depending on the use case, I can still send this information. Say, for example, the number of cars during the day at that particular point. My centralized traffic controller might not need. Depends on how I implement that, what kind of capability I want to add to it. But yes, what we have planned is like you can have the localized analytics at the edge and the central. Then you can send rest of the information at the central server, where you can do the bigger analytics, including all the traffic signals.
Would you believe it or not, the city of Los Angeles has already done this?
Mm-hmm. Interesting.
Would you believe it or not, but the city of Los Angeles has already done this? They have a very large and a very effective system that I'm aware of.
Interesting. I would love to go in deep into that, because I have been trying to search internet, but I'm not able to find a use case or somebody who has done it this kind of a system. I mean, which is very centralized and using the edge computing as well. So yeah, that's something good to read for me as well. Sorry?
We could talk later.
Absolutely.
I'm KRS Murthy. Las Vegas has done it.
Mm-hmm.
And talk to me, I will give you a big list of the places in China,
mm-hmm,
in Japan, in Korea, and other places. I personally know what they're doing.
Interesting. Sure, I'll get into you. Okay. Just quickly. We'll quickly touch what is edge computing. I think as explained earlier as well. If I can, so basically if I can bring computing capability at my radio edge, be it carrier or non-carrier, that's we typically call it mobile edge computing, or now it has been renamed as multi-access edge computing. So what all capabilities gives you? It gives you flexible application deployment and service deployment based on the use case needs. What kind of use case, if it really makes sense to deploy it at the edge, yes, definitely that is the place we can do it. Now, where this edge server can sit, it can sit the proximity of my radio, it can sit at the proximity of my code, depending on what you want to achieve. If it is a very low latency application that we want to develop or deploy on top of them, definitely has to be very, very close to the radio, because there's no point deploying it at the core edge. Okay, so as part of NEV SDK, we will be covering most of the mobile edge host infrastructure here. Now, NEV SDK, I think we have already gone through this architecture diagram in previous session. So we have two major components here: the mobile edge computing platform, which takes care of my multiple services, the traffic rules, the DNS service, and the network information service, along with the service registry, which takes care of all my services and application registration management. Along with that, one of the key component is the mobile edge platform manager, which takes care of application registration. Now, as per the current architecture and current implementation, we will go about that in detail in the later part of the session, but for the quick overview, once an application comes up, before that my manager has to go and register it to the MEC platform, so that once application comes up, it can go and tell the platform that I am alive and can you give me a reference ID. So I'll go about those reference IDs and everything in detail in the later part of the session, but for now we'll be covering three major part of this entire architecture. One, the reference point MM5, which is the management interface between platform and the manager. Second, the platform and the application interface, which is MP1, the reference point. The last, the data plane. So we will also briefly touch upon how the data plane programming has to be done, because we are using the DPDK as part of the data plane here, data plane processing. So we'll just briefly touch upon that as well. Just quickly, the scope of the APIs that we are going to talk about. The scope of the APIs is between ME Manager, ME Platform, and the ME applications. Okay, now let's look at the management APIs. So these are the three major procedures available from management point of view: application configuration, application termination, and connection establishment. So what is application management? When we say application management, application configuration, we talk about before any application can go live on my radio edge, it first needs to be registered with edge platform, so that my edge platform knows about the application. It will authenticate it, and it will add key traffic routes. Based on these routes, my network traffic will start moving towards the application or towards the core. So let's pick up application configuration first. Okay, so from an application, as a developer community, it's very important to understand how do I design my application so that once it is registered with the ME platform, I should be able to register myself appropriately with the right set of parameters. So on this side of the block shows me what kind of request body should go with me with the application configuration. So once ME Manager registers the application, these kind of so you have to send the application ID, a secret key which is unique to the application, or rather not unique but the private to the application. It can also register for subscribable services. So my application can register itself as an application which will consume the services, or it can produce the services which can be consumed by other applications. So I can subscribe as a producer or consumer. So in this template shows of a consumer. So you can see the provider app ID. So say app ID 2 is the one which will be producing some parameter which I should be able to consume.
Can you give an example?
Sorry?
Can you give an example?
Example, if you go back to the previous application which I just showed in the start, my analytics controller is the producer, where my analytics engine, my analytics engine is the producer, whereas my local controller is the consumer in that case. So it goes and gives the entire analytics data towards my application, so local controller, which it's feed into the local controller so the entire traffic flows via NES in this case. So it will generate traffic based on the traffic it receives. It is also, so it can register as a producer as well as a consumer. So if I have to, I'll get data from the UE, but I'll produce that information to other apps. So I'll process it and send that information to other apps in more sensible fashion. Okay. So, then the another important factor while configuration is the traffic rules. This is pretty important here, because unless until our traffic rules are correct, my data will from the UE or from the apps will not flow towards me. So the certain parameters which needs to be very, very precise. Number one, which VM ID. So once you register a virtual machine or an app, which is typically a virtual machine in this case, you need to provide the MAC address and the VM ID, which is actually registered with my virtual infrastructure. So based on that, my DPDK will know, okay, this is MAC address I'm supposed to send the traffic to. Then there are the certain other parameters like update permitted, yes, or removal permitted. So can application go and update or remove those parameters or update traffic rules in future? There's another, so this is the key, the rule fields. Because the rule fields will tell you, okay, once I receive the traffic, what I'm supposed to do with that. So for the name, there are certain categories like server IP, if it is UE IP or eNodeB IP, or what kind of a protocol I can support. I will go in about them in detail when we talk about the traffic rule creation. But that's something as is a critical part of the application configuration itself. Moving on, application termination. Excuse me. So application termination, when we talk about, it's like ME manager again has to send the termination request. So once ME manager sends the termination request, it's pass on that request to ME app and sends a notification back. But at the same time, it has to initiate the termination by the application itself. It's not that it will go and abruptly shut down my application. So application has to gracefully shut down. It will wait for a timeout period before it will abruptly shut down. So you can see that in the request body, I have to send the graceful termination timeout period, which is in seconds, and then the app ID. So yeah. So I think I should have put up this before the termination. The manager connection establishment, this is an interesting API basically. So once ME manager comes up, it has to go and register itself for any notification coming from platform. So if it needs any notification, it should have first registered itself as a listener. So once you initiate the notification request, it will go and open a WebSocket with the application. And once it opens a WebSocket application, whenever there's a new notification which is supposed to go for ME manager, it will immediately forward it to ME manager. So for example, once if I roll back to the previous slide, if you look into this slide, the last line, the termination notification. So even though it has got the termination response, but once the app goes down, it gracefully shut down, it will still get a termination notification that this particular app has gone down. So that from a management point of view, I should be able to manage the current state of each application and services deployed on my infrastructure. Okay, let's jump to ME app APIs. So these are the current APIs available from an application point of view. The first is live indicator. So I'll go about them in detail in subsequent slides. Let me just fast. Okay, the live indicator. Okay, now this is one of the important APIs for application point of view. Once an application is registered by ME app, so it first has to fire this API to get the reference ID, which is more like an authentication. Once it registers itself, it will come back with the reference ID, something like this at the bottom of the screen, which has to be used in all the subsequent requests. Unless until you have this reference ID, it will not be able to authenticate, or the ME platform will not know if you are already registered with me or not. So all you need to send is the application ID, the same secret key what my ME manager has sent during the application registration or application configuration, and what type of ME app it is. Is it an ME app or ME app service, as we spoke in previously. So it can register it as an ME app or ME service, which is a producer or a consumer. Similarly, I can delete. So once I deregistered, it will send a termination request, as we saw in the previous ME manager's termination request slide. Now that was initiation by the ME manager. The same thing can be done by ME app. ME app can also initiate the termination request. So same rules applies here. It will send a termination indicator. Once I get the response, it will notify all the services which are either consuming the application services from this particular app, or and the ME manager as well, that this particular application has gone down. So all we need to use, we have to ensure that in my header, I should use a cookie with session ID and the reference ID that we got. Okay, again the connection establishment. This is again important for receiving the notifications from all the other services. And this is pretty much same as what we did in ME manager, except for one thing, that we still have to use the reference ID in the URL. Okay, this service activation API is an interesting one. So once I registers as an application, now if I want to consume any new services which are deployed in the system, I can still do that. All I have to do is fire a service activation request with again my service ID, and I'll get a response. I have to tell my platform what all services I want to activate for. So if you are authorized to use those applications, those notifications will start coming to you. For service deactivation, similarly, we just have to send the service ID, and that's it. And the reference ID, yes. So we again have to use the reference ID in all the. So whenever we are developing an edge application, we have to ensure that once my application comes up, it should first send the live indicator and get the reference ID, which has to be used in all subsequent requests. So it doesn't need to fire a live indicator every time before it sends, but once the application comes up. Okay, now let's see how do I know what all services are available. okay, I register for some certain services, I'm able to activate the service, but how do I know which services are available for me to subscribe for? So there's another API called Service Discovery API, which helps me get the list of subscribable services from any platform. So it gives me a list of all the services which are available, and I can go ahead and register for those services and start getting notifications from them. This is how I subscribe the services. I can the subscription, the service ID which I want, and I can just send this details. Okay, if it is an integer, what service ID is, all the other parameters I can send out. Similarly, I can go and do some service data update and publications. If I have to publish some services, this is how I do it. So when I use this particular notification thing, so you can see that data update request. So for example, if one particular service wants to publish this information to all the other services which are listening to that particular data point. So once it will send to the ME platform will check into the database, okay, which all services or which all applications wants this or are interested in this particular information, and they will send the notification to all of them. Okay. They were more of the ME app APIs. Now the three important traffic rule APIs. How do I create a new traffic rule, and how do I create or update or delete a traffic rule? Now, when we see, I was talking about the traffic earlier, and what kind of an application we do have in here. So you can see that we have this producer app and consumer app, and who can produce it. So how the traffic routes from VM1, say VM0 and VM2 and VM3. So they all can go via my edge platform, or they can also talk to them directly, which is a standard case of as of today, which is over the internet. But in this case, if they register itself with the edge platform takes care of publishing it to all the application registered. Similarly, I can directly do a producer app and a consumer. They can talk to each other via WebSocket or a standard subscription with notification. So this is how we create a traffic rule. Again, I have to use my reference ID, and in the request body, in the result body, okay, sorry, I mistakenly write as the result body. That should be the request body. The request body should contain what kind of rule I want to create. So for example, in this case, I'm showing what kind of an encapsulation this rules will apply. Say it can be GTPU or an IP traffic. Then what is the service IP that I'm interested in? So if it is, say, this particular service, if this particular packet is intended for this particular server IP, forward it to me. So it will go and forward that particular IP to that, the data to that particular VM. So what does it mean is, any traffic coming on DPDK port which is intended for 192.168.10.11 with an IP mask of 24, and if it is a GTP packet, please forward it to VMID2 with this particular MAC address. Similarly, you can do an update. All you have to ensure that the traffic ID which you receive here should be used while firing this API. Okay, before I move on, any questions?
This API looks very similar to OpenStack APIs. So why are we developing something new and not just extend some of the OpenStack framework?
So this framework sits on the OpenStack itself. So this is one of the as a network function which sits on the OpenStack framework. I can say that, because ultimately the data plane is we are using the OpenStack platform to deploy this infrastructure. So the MEC manager itself will talk to the virtual infrastructure manager, be it OpenStack or anything else, and it can create. It has to basically deploy the VMs once you have to instantiate an application. So I'll use the OpenStack APIs to create the applications there.
Okay. Yes, it resembles very much.
Yes. Now, so there are two ways of handling this data at my application level. Once I get the data at my application, how do I handle it? Either I use my existing Linux APIs to receive and process this data, or I can use the L2 forwarding provided by DPDK. This is one of the examples how in which particular scenario, say in this scenario where my eNodeB sends out in data to NES for a particular VM, and if the VM has to send a response back to the VM rather than forwarding it to EPC. So in this particular scenario, what we need to do, we can use this, we can switch the inner destination and source IP address and send on the same port as my. So basically what I'll do is I'll get the source IP as source port and the destination port in the request, and just swap it and send the packet back. So I have to handle that during my application development. When I'm doing my application development at the edge, I need to take care of those things programmatically rather than doing it or relying on the L3 forwarding. This is just one way of doing it, but there could be many other ways. Okay, quick hands-on time.
Hi, thank you everyone who are there online. We'll be switching off the stream now because people in the room will be doing hands-on lab. So thank you for joining.